example for the analysis of a determinate frame. So for example, we have this frame A, B, C, D, E. So A and E are hinge supports. At C, we have an internal pin. So the uniform load, okay, that is 6 kilonewtons per meter. So for example, we may do the complete analysis of member A, B, and B, C. The analysis of these two members are somehow similar to CD at saka si DE. Okay, so I'll be just doing A, B, and B, C. Okay, so for this case, we may have the total equivalent weight of this uniform load. That is the same as 6 times the span 8. So a total of 48 kilonewtons. So its concentration is acting at point C. So I will do summation moment about A equal to 0, clockwise moments to be positive. So first thing to do, compute for the support reaction. And the vertical reaction at E, the vertical reaction at A, horizontal reaction at E, and horizontal reaction at A. So summation moment about A equal to 0, that is the same as 48 times 4 minus E vertical divided by 8 equal to 48 times 8 pala. Ito nga, 48 times 4 minus E vertical times 8 equal to 0. So 48 divided by 8 is 6 times 4. E vertical is equal to 24 kilonewtons. Summation forces vertical equal to 0, upward forces to be positive. A vertical plus E vertical 24 minus 48 equal to 0. So obviously, A vertical is the same as 24 kilonewtons. These are the support reactions. So obviously naman, since symmetrical loading ito, we'll be having equal support reactions. So after determining the vertical reaction, since this is an internal pin, we may separate this member A, B, C or C, D, E. Okay, so let's do A, B, C. So we have the number A, B, C. Half of the span is 4 meters. So let's compute for this forces. Let's say C vertical and C horizontal. Okay, for example, I'll be computing for A horizontal. Makuha natin yan by summation moment about C equal to 0, clockwise moments to be positive. So that will be clockwise. That is yung A vertical kanina. That is 24 kilonewton times. Okay, this span is 4 meters minus. We have A horizontal divided by yung total height ng frame. That is 8 meters minus. This is 6 times 4. That is the equivalent resultant. Acting midway times 2 equal to 0. So what will be the magnitude of A horizontal? This will be equal to 6 kilonewtons. By summation of forces, horizontal equal to 0, for the right forces to be positive, this is 6 A horizontal. Okay, other than that, wala namang ibang horizontal force maliban kay CH. Minus C horizontal equal to 0. Horizontal reaction at C is the same as 6 kilonewtons. Then summation of forces vertical equal to 0, upward forces to be positive. We'll be having 24 minus 6 times 4, that is the same as 24, plus CB Then do we have any other vertical force? Ay, wala. Equal to 0. So therefore, we don't have a vertical reaction at that internal pin. CB is equal to 0. So these are the support reactions. So let us analyze per span. That is, first column AB, then this member BC. And so let us analyze member AB. So since that is just a bend, so it is considered as fixed. Kung ikakat natin yung portion na to, that is considered to be a fixed portion. So, or an exposed fixed portion of this member A, B, C. So at A we have the vertical reaction, that is the same as an action load. So for the action load, if this is 24 upward, to be in equilibrium, we need 24 kilonewtons downward. If this is 6 kilonewtons to the right, for equilibrium, we need 6 kilonewtons to the left. Alright? Then since this is fixed support, we will be having a moment about point B. I'll be assuming that this moment is clockwise muna. So this is summation. Let us compute for the equivalent moment at B. This is the summation moment about B equal to 0, clockwise moments to be positive. What are the clockwise moment about point B? Okay, yun lang yung moment. This is M sub B. And we have M sub B minus 6. What is the span of this beam or height? That is column pala. This is 5 meters. That is the same as 6 times 5 equal to 0. So we have correct assumption. The moment at point B, considering member AB, should be clockwise. M sub B is now equal to 30 kilonewton meter. Okay, so let us now do the equivalent shear diagram, moment diagram for this member. Okay, first, we have the shear diagram. So starting at A, we have that is 6 kilonewtons towards the negative direction. Kung i-rotate natin ito, this will be the top of the beam. Kumbaga, yung ibabaw na top of the column on the left side. Ito yung ilalim. So we'll be having that is towards the negative direction, negative 6. We don't have any shear all throughout its length. So diretso lang ito hanggang sa dulo. So this is negative 6, then 6 towards the positive direction. This is the same as negative 6, that will make it 0. So this will be our shear diagram. So it will be the equivalent of the moment diagram. Okay, so for the moment diagram, so obviously since this is a hinge support, the moment is 0. So we have the value of the moment is equal to the area of the shear diagram. What is the area of this diagram? That is the same as negative 6. Negative 6 times the height, we have 5. So we have a total moment up to point B equal to negative 30 kilonewton meter. So I hope wala kayong problema from your strength of materials. So since this is ano yung degree nito? 0 degree horizontal. For a straight line diagram, that is 0 degree. So obviously, the next diagram should be first degree. So this is from 0 to negative 30 kilonewton meter. But at point B, what is the value of moment at point B? It is a clockwise moment. So which means this is positive 30 kilonewton meter. So we'll be having 30 plus negative 30, that will give us 0. So this will be the equivalent of the moment diagram for member AB. And lastly, for the action load, for the action load diagram, so as you can see, we have an action load of 24 kilonewtons, that is compression. So we may represent the diagram as a diagram straight line with a negative 24 Okay, the negative sign means it is under compression. So this will be the complete analysis for member AB. Okay, so next, we may proceed to member BC. Okay, so we proceed to member BC. So kung kanina from the other end ng member AB natin, for example, we have this is a member AB kanina. So if this 24 kilonewtons downward, considering member AB, if you have to proceed with member BC, it should be upward. Then kanina rin for member AB, we have the 6 kilonewtons is to the left. So if you have to transfer on member BC, it should be to the right. Alright? So this will be the direction of these forces at point B. But as you can see, we have an incline member, tapos yung load natin is vertical. So we need to convert this one, the 6 kilonewtons per meter, into perpendicular load to the member. So kailangan natin siyang gawing perpendicular. This load will be having a component that is perpendicular to the member. This is one of its component and parallel to the member. Okay? So we need to convert those. We need to convert this 6 kilonewtons to its corresponding elements. Perpendicular sa member and parallel sa member. So the slope of this member is, ano ba yung slope ni BC? The slope is 3 vertical, 4 horizontal, 5. So this is 3, 4, 5 triangle. So usually, what is the equivalent of that 6 kilonewtons? This 6 kilonewtons is the same as 6 times the span. So 6 times 4, a total of 24 kilonewtons. So how do we distribute that? Okay, so let us have its equivalent. So again, if you are to remove this 6 kilonewtons, its concentrated load equivalent will be 24 kilonewtons. So if this is the 24 kilonewtons, okay, so let's consider the slope, 3 vertical, 4 horizontal. It's the same as we'll be having its components 3 parallel to the member, and its component 4 perpendicular to the member. So if you are, pwede nyo i-check geometrically that this angle is the same as this. Yung angle dito is the same as this one. Okay? So you may check that. So all you have to do is get the equivalent component at 3, then divided by the length of 5 meters. Take note, this is 5 meters. So for, let's say, for our axis, this is x-axis. Ito naman yung y-axis. Let us determine the equivalent of the parallel. So we have the uniform load, x, that is the same as 3. 3 over 5 of the equivalent resultant load of that 6 kilonewtons per meter, that is 24. So 3 over 5, then divided by its length. What is the length of this member? This member is 5 meters. So divided by 5. So we have the uniform load, x is now equal to so we have an equivalent of 2.88. So take note, this is kilonewtons, 5 is 5 meters, so this is now kilonewtons per meter. So yun na yung ating magiging axial load. Kumbaga uniformly distributed load throughout its length pero parallel. This is the uniform load along X equal to 2.88 kilonewtons per meter. So ngayon naman, kunin natin yung isa pang component which is 4. So this, yung Y naman, if this is our Y axis, that is the uniform load perpendicular sa member. So we'll be having omega Y is now equal to, that component is 4 over 5 of 24 kilonewtons. That is to be distributed all throughout the length. So divided by 5 meters. So we have the uniform load along Y, perpendicular load natin. So that will be 4 over 5 of 24 divided by 5. So we have a uniform load of 3.84 kilonewtons per meter. So, kung tatanggalin na natin yung 24, we may remove this 24 since we have the equivalence. So, we have the equivalence. So again, this is our y-axis. Ito naman yung x. So, we have now the uniformly distributed axial load, 2.88 kilonewton meter. Tapos, yung equivalent naman na perpendicular sa member. So this is the omega sub y. So omega sub y is equal to 3.84 kilonewtons per meter. So after setting those equivalent load of that 6 kilonewton per meter, so pwede natin gawin yung complete analysis for member BC. So let us now do the analysis for member BC. So we have again the reactions at B. Sama lang din natin. So at joint B from member AB kanina, it is clockwise. So if you transfer to member BC, it will be counterclockwise. So it should to be a negative moment. So we have the equivalent of that 6 kilonewton per meter for span BC. That is 3.84 kilonewtons per meter perpendicular, 2.88 kilonewton per meter axial. Okay? So let us determine the components. So what will be the component of this? For example, solve muna natin yung total axial load acting on member BC. So what will be the equivalent force or component of 24 that is axial to member BC. So ano yung magiging slope nito? So let us observe the slope. The slope is 3 vertical, 4 horizontal. Okay, so this will be for this angle, so ito 90 degrees, then so 36 is 90. Okay, so this will be for this is 3 3, 4, and 5. What about for 6? The opposite, that is, so which means the equivalent slope will be, this is 4 and this is 3. Okay, so you may check this slopes or components of 24 and 6. That is parallel or perpendicular to member BC. So let's say this will be the axial force for member BC along X. So ito yung axis natin. Again, this is x-axis. This is our new y-axis. What is the value of b sub x? So we have Bx is equal to 24, the parallel component. We have 24, that component is 3 over, this is 3 over 5. Plus, for the 6 kilonewtons, that will be 4 over 5 of 6 kilonewtons. So this will be the axial force. Yung axial force na matatransfer for member BC from the reactions B24 and 6. So let's compute for that value. And we have 24 times 3 over 5 plus 4 over 5 of 6. So we'll be having a value of B sub x equal to 19.2 kilonewtons. That will be the axial force at point B. We have 19.2 kilonewtons. Okay, the actual force. How about this one? Ano yung magiging equivalent? Okay, so this is x-axis. What will be the equivalent? Let's say this is c sub x. So ano naman yung angle na to? This is the same as... yes. So if this is the 6 kilonewtons, its equivalent angle, I think dapat pareho lang dito. So the parallel will be 4 and the perpendicular should be 3. So what is the value of c sub x? Okay, the value of c sub x should be 4. Okay, 4 over 5 of 6. And then it's equal to? So 4 over 5 of 6 kilonewtons is equal to 4. This will be equal to 4.8 kilonewtons. Okay, those are the actual force per point. At point B, we have 19.2. At point C, the actual force is 4.8 kilonewtons. Now, we need to determine the equivalent forces perpendicular to the member. Okay, that will be parang equivalent support reaction. Okay, so this is, again, this is your new y-axis. Ito yung ating bagong y-axis. So this is, let's say, this is B sub y. That is the perpendicular reaction. Okay, let us compute for B sub y and the equivalent perpendicular reaction at C. Let's say this is C sub y. Okay, so what is the equivalent of B sub y? That will be 4 over 5 of 24 minus, ito kasi pababa yung kanyang perpendicular component of the member. Okay? So, yung B sub y, we'll be having the equivalent of B sub y as 24. What is the component of 24 perpendicular to the member? That is the B sub y. 4 over 5. That will be 4 over 5. Ay minus 6. What is its component perpendicular to the member? That is, we have 3 over 5 of 6. So we'll be having the equivalent of B sub y. So this is 24 times 4 over 5 minus 3 over 5 of 6. That will be equal to? This is equal to 15.6 kilonewtons. Then we may check this one, this 6 kilonewtons. So ang kanyang component naman na perpendicular is the same, yun yung 3 over 5. Okay, so for 6 of y, 3 over 5 of 6. So for 6 of y, that is 3 over 5 of 6. And this is now equal to, we have 3.6 kilonewtons. So those are the reactions, the reactions perpendicular to member BC. So this is 3.6 kilonewtons. So after that, we may now do the shear moment diagram. Shear moment diagram plus the actual load diagram. So parang gawin natin ganito. Incline din siya. So first, let us do the shear diagram. So we have here, what is the value of B sub y? We have the value of B sub y is equal to 15.6. So it is positive. So from 0, akit tayo dito with a value of 15.6. Then this is 15.6 minus 3.84. Ano yung kanyang equivalent resultant? 3.84 times 5. That's the same as 19.2. So what will be that value? So we have 15.6 minus 19.2. 15.6 minus 19.2. So we'll be having a negative, or is equal to negative 3.6. So this will be the equivalent of the shear diagram. So here we have negative 3.6. We have a reaction perpendicular to the member. That is 3.6. That will make it 0. O, yun yung ating shear diagram. So let us just compute for this one, x. Ito naman, 5 minus x. Variation proportion of similar triangles. Okay, so this will be 15.6 is to 5 minus x. Kabila naman, equal to 3.6 is to x. So this will be equal to 0.9375 meter. So we can now compute for the moment. Let's say this is point A. Okay, so starting at point B, take note that we have a counterclockwise moment at point B, that is negative 30. So we have to start with a magnitude of, let's say this is negative 30 kilonewtons, kilonewton meter. So what will be the moment about point A? So you have the moment about point A is negative 30 plus, since this is a positive shear, ay 1/2, ano yung kanyang base? That is 5 minus 0. Yung value na to, 0.9375. Then yung height, or the height is equal to 15 point. And this is 15.6. So we have the moment at A, that is the same as the moment at 0 shear for span BC. So negative 30 plus also we having a moment equal to 1.6875 kilonewton meter. Or it's the same as, okay, sabihin na lang natin 1.69 kilonewton meter. So negative 30, this is from positive shear to 0 shear. Okay, so the magnitude, maximum positive moment for this span BC, 1.69 kilonewton meter. And let us check. So dapat yung moment sa C should be 0 since that is an internal hinge. So we have the moment at C is equal to, okay, gamitin mo yung buo, 1.6875 plus 1/2. The base is 0.9375. Tapos we have, this is negative 3.6, so negative shear. So we have the moment at C, 1.6875 plus 1/2 of 0.9375 times negative 3.6. So obviously that should be equal to 0. So this will be our moment diagram. Then for the axial load diagram, okay, so as you can see here, we have 19.2 kilonewtons that is compressing the member. So all you have to do is dapat lang mag-match lang yung mga downward or upward to the force parallel to the member or along the axis of the member. 19.2 should be equal to 2.88 times the span plus the component of this 6 kilonewtons, which is the 4.8. So we have to start here at negative 19.2. So we have, let's say the axial force at C is equal to negative 19.2, or parang checking na lang yung gagawin ko dito. That is 19.2 should be equal to, okay, we have 2.88 multiplied by the total span of 5 meters plus this 6 kilonewtons has a component parallel to member BC with a magnitude of 4.8. So this is plus 4.8. So this is 19.2. So what is the equivalent of the right side? So this is 2.88 plus 4.8. 2.88 times 5 plus 4.8. This is the same as 19.2. Okay? But as you can see, this is distributed all throughout the length. So which means mag-first degree tayo. From 19.2 papuntang negative 4.8. Yeah. So first degree for a reason, we have a uniformly distributed axial force all throughout the length of the member. Okay? So this is our example. So this will be the equivalent axial load diagram. Okay, so for the degree of the shield, this is first degree, this is second.